Good evening, grade 8s. I wonder if you're doing this actually at the halftime of the Grey Cup or not. Is Edmonton winning? Is Ottawa winning? Anyways, so today's video is going to be on 1.7, applying the Pythagorean Theorem. It is the last lesson on Pythagorean Theorem. I know, you're probably sad. You'll get over it. I did once when I was in grade 8 as well. So what we're going to do is we're going to actually take a look at the theorem, have some different situations where you can apply it, and you can tell me if we're looking at a right triangle or not. Okay, so let's get started. In all our time talking about Pythagorean theorem over the last 4 lessons, we never actually said what the formula was. Well, you know what? It's right there in front of you. Pythagorean's theorem is a squared plus b squared equals c squared. That's as simple as it gets. Now, let's see what exactly this Pythagorean guy meant when he said a squared plus b squared equals c squared. Well, let's look at an example of a triangle. Right here, we have a right triangle. We know it's a right triangle, even though it's a very bad sketch. This little box right here tells us it's a right triangle. Now, what we've learned is the two sides that form the right triangle we call the legs, and the side opposite the 90-degree angle we call the hypotenuse, or we also know that the hypotenuse is the longest side in a right triangle. Well, with Pythagorean's theorem, a squared plus b squared equals c squared, all he basically did is, it's quite simple. He took one of the legs and he called that side, we'll go a different color. He just took one of the legs, and instead of calling it the leg squared, he just called the leg A. And the other leg, he called B. Now, these are interchangeable. It doesn't matter what leg you call A, what leg you call B. No. But you just got to remember the legs are A and B in Pythagorean's theorem. So up here, basically what he's saying is the square of the one leg added to the square of the other leg should equal c squared. Now, in this case, instead of writing hypotenuse all the time, which no one would like to do since it's such a long word, he just changed the word hypotenuse and he put the word c. So the legs are always A and B, and the hypotenuse is always referred to as c. So that's how he said the square of A plus the square of B equals the square of c. Does that make sense? Well, let's go apply it to real life here. So with Pythagorean's theorem, let's in this case make this side right here A. So what he's saying is if we square this, in this case 4 squared is 16, and this will be our other leg, so this could be B, and we know 7 squared is 49. We take the leg off our hypotenuse, but in Pythagorean's theorem, this square right here, or did I call it a leg? I apologize. This side, 8, we know that's 64. So using Pythagorean's theorem, he's saying if you take the square of the A, in this case, 16, so let's just do it right here. He's saying if we take the square off A and we add it to the square, this remember little 2 is another way of saying b squared. If we take the square off of b, in this case right here, 49, if we add 16 to 49, it should equal whatever the square is off here. And in this case, we said the square off of c, or our hypotenuse side, is 64. Well, is this true? Let's guess. All right, let's figure this out. 40 plus 10 is 50. 9 plus 6 is 15. You know what? This is not an example. It's close. It's very, very close, but it's not an example, because we know these squares, when you add them up, should equal this number. In this case, 49 plus 16 is actually equal to 65. So we're very close, but it's not an example. So that's my bad. That shouldn't be there. Okay, there you go. Let's try another question here. Check this out. Marina helped her dad build a small rectangular table for her bedroom. The tabletop has a length of 56 centimeters and a width of 33. The diagonal of the tabletop measures 60 centimeters. Does the tabletop have square corners? Hint, a square corner means right angle. So basically what they're saying is this angle right here, where this leg and this leg meet, is it a 90 degree? Well, we can use Pythagorean's theorem. So we know that a squared plus b squared should equal c squared. Okay, well, let's start plugging in numbers here. If this is our triangle right here, I'm just going to really quickly highlight it. So if this is our triangle we're dealing with, our legs would be the ones that form the 90 degrees. So in this case, it's 33 and 56. Does it matter which one's A and which one's B? It doesn't, so we can just plug it into our formula here. So we will take 33 and we'll call that A. So anywhere we see A, we go and replace it with the number 33. It's also very important to remember that we need to have this little squared sign here still. Okay. See, all I did was take the A out and replace it with 33. What about B? Well, that would be the other leg, and in this case, 56. We're dealing with some big numbers here, folks, but that's okay. We have calculators on these computers. We're going to use them. So I replace the number 56 wherever B is, and I bring down that squared sign still. Okay. And in this case, C, we do know that even though it doesn't say it here, up here in the question, it said the diagonal measured 60 centimeters. So she went, Marina later went and measured it at 60 centimeters. So let's put that in there. So wherever C is, we'll put 60, and then we put this little squared. Okay, let's pull up our calculator and see if we can figure this out. So 33 squared, 33 times 33 is equal to 1,089. Okay. Plus, okay, let's pull it back up. Where's the calculator here? Where's that? We'll go 56 squared, so we know that's 56 times 56. I have a feeling it's going to be a big number. 3,136, did it say? Yeah. Okay. Now, if we add those up, it should give us the same number here if it's a right triangle. So what's 60 squared? Well, I know 6 times 6 is 36. And add 2 zeros. I think it's going to be 3,600, but let's just double check that. It is 3,600. Okay. So we know the area off of this side, off this square, is 1,089. We know the area of this side is 3,136. If we add them together and we get this number, we know that this angle is 90 degrees. Let's go back to our calculator. Let's go 1089 plus 3,136 equals 4,225. So is this equal to 3,600? Nope. So guess what? This is, I'll go orange. This is not an example of this isn't square right here. That's not a square angle, so you can't have that sign there. Okay. Wow, let's see if we can actually find one that works. I realize I've been talking quite a bit, and I'm reaching my limit, so I'm going to pause this, and I'm going to have to make it 2 parts today. Okay, so I'll see you in the second part, grade 8s. We'll do one more question, and then I'll leave you with a question to answer on Edmodo.